Hello Internet, my name is Quinn and this is Blondihacks. I'm working on my A3 locomotive this week. We've been working on the lubrication system, but once again we have to put that system on hold due to some dependencies, and I'm going to switch gears and start working on the fire management system. Steam locomotives need one of those, and we're going to start with the fire grate. So let's go. Previously we started on the water system and the lubrication system, and I was not exaggerating when I said locomotives have a fire management system. There's actually a lot that goes into building and managing the coal fire. There's two holes in the frame where the ash pan attaches, and there's some rails that the fire grate slides into. The firebox on the bottom of the boiler is open, as you can see on the bottom, and the boiler sits down in that little recess in the frame. The fire grate thus sits flush up against the bottom of the firebox and supports the bottom of the coal fire. And the idea is the coal fire is completely surrounded by a water jacket in that double-walled section of the boiler so that it can't melt the metal that the boiler is made of. Of course, a coal fire is white hot and perfectly capable of melting any metal that you put around it. This is also a great reminder that as beautiful and sophisticated and complex as steam locomotives are, at the end of the day, they're a fancy metal box around a campfire. It's hard to overstate the importance of the fire grate in a locomotive. If you're new to steam technology, you might think it's just whatever size metal grill happens to fit underneath the boiler and it holds up the fire and that's the end of it. But in fact, the surface area of the grate is one of the primary design considerations for every solid fuel powered locomotive and steam engine. It's somewhat analogous to displacement in an internal combustion engine. The area of that grate is your starting point for all the power that you may or may not get out of that locomotive. You start with grate area, and then you design everything else around that based on how much power you're going to need the locomotive to produce. The power comes from the size of the fire. Everything else is just efficiency, just trying to capture as much of that heat and use it as efficiently as possible. So this is your starting point, and it's all downhill from here. It's a pretty simple looking assembly. It's a lot of repetitive work, but that actually gives me a chance to talk about some basic mass production techniques in a hobby shop, because we have a lot of the same parts to make. In this case, I'm cutting apart the grate bars. This is all 303 stainless. The fire grate has to be all stainless because it needs to be steel to stand up to the heat of the coal fire. It's under the coal fire, but still exposed to most of the heat of it. And it has to be uncoated because there's no paint or powder coating of any sort that can stand up to the heat of a coal fire, and we don't want it to rust. Thus, we land on stainless. In addition to talking about some mass production methods, I'm also going to be showing a little more detail than I usually do in these videos. It's a nice change for me to be able to show you some of the stuff that normally gets cut out because these are such simple parts. For example, after all that bandsaw cutting, every single edge that we just created gets deburred. That's 4 edges per end of all 8 bars. That's 64 edges, and it is important that we deburr after that bandsaw cutting, even though we're about to set it up in a machine tool and recut those edges, because burrs mess up everything that you might be about to do. Burrs will keep parts from being clamped properly, they will mess up edge finding, they will keep parts from sitting down on parallels properly. You've got to deburr early and often. But now with all those edges cleaned up, we can set up in the mill, and I'm going to start by bringing all these bars to final finished length. And here's where we get into a little bit of mass production. So I'm going to start by cleaning up one end of each bar, just minimal surface removal to clean up the ends. We're not measuring anything yet. I can cycle through all the bars, and there's no setup or measuring required here. I'm just touching off and taking a light cut on one end of all 8 bars. Then, and this may shock and amaze you, we have to deburr again because we've just recut those surfaces. We've created 4 new burred edges. So all 4 of those edges on every piece on one end has to get deburred again because we're going to be setting these pieces up the other way in the vise. So again, we got to get the burrs out of the way of the vise jaws and the parallels. There we have clean machined and deburred edges on one end of every single bar, but the other ends are still rough bandsaw cut. Now from here, I'm going to focus on one piece for a minute. I'm going to do what's called a setup piece, if you like. That's what I call it. And I'm going to put it back in the vise, making sure that after I cut it down to final length, that it will still fit in the vise with a little bit sticking out. In other words, I need to be able to face it all the way down to final length without touching the vise jaws and without having to move it in the setup. I again do one light cleanup cut on this end, and now I can measure it for the first time. Now I see where I am right now without moving the table on the X. That's important. I haven't moved the table since taking that light cut. I measure where I'm at now, and I punch that dimension into the x-axis on my DRO. So the DRO now knows that the cutter is on the end of that part and where that is. That matches my measurement. Now I can go back and side mill my way down to the final desired measurement, which in this case happens to be 3.750. You don't have to have a DRO to do this. I'll show you another way in a minute. But for this DRO method, I machine that down to 3,750 on the DRO, and then I double check that measurement before I go anywhere else with the micrometer, because this is my setup piece. All other pieces are going to be cut to this same position. So that's a correct measurement. I'm happy with that. Now I can put an end stop in there. This first piece, the setup piece, is complete. I can set it aside. Now here comes the mass production magic. That setup will cut every subsequent piece perfectly to length, as we did that first one. I cycle the other 7 pieces through now, making sure to put the bandsaw cut outward and the machined face up against the end stop, and I can cut down to that same 3,750 on the DRO. Now, if you do this all super well, you can get each piece to the point where all you have to do is a single finishing cut on each one, like if your bandsaw cutting is really accurate, but it doesn't have to be in this case. I had 2 or 3 passes I needed to make on each part, just depending on how much of a depth of cut you want to take on each pass. So touch off on the end of each bandsaw cut wherever it happens to be, and machine your way down to that 3,750 on the DRO, and all the pieces are going to come out identical and on dimension. Thus, we only measured twice, but we got 8 perfectly dimensioned bars. And yeah, guess what? Deburring time. Yeah, now we have to deburr the other ends of all of those pieces that we just cut. Now you see why I usually edit this out, but it is important, and I'm happy to call attention to it for these parts. Don't let yourself move on to the next cut until you can't feel anything sharp on any edge or corner of that part. Everything should be smooth and soft to the touch. Your fingers are very good at that. So just like that, I have 8 bars that are all perfectly identical in length, square on the ends, and on dimension, most importantly. I do need to narrow these bars up, though. They are too wide. I couldn't get nominal bar stock the correct width, so I'm going to do that on the shaper. So now I'm going to show you some mass production on the shaper and without a DRO. So very similar to how I did the ends, I'm going to start with a setup piece on the shaper. I'm going to do a light minimal material removal cut on one edge of the first part, just to get myself a reference edge from which we can measure. As an aside, this is actually my first time cutting stainless on the shaper, and these kinds of parts are the perfect chance to experiment on a machine with speeds and feeds and new materials, because the parts are very simple. If I scrap one of them, it's no big deal, and the dimensions on them aren't really that critical. So it's a perfect learning opportunity to experiment. So look for those opportunities when you're trying out new materials or new methods. Honestly, that finish is excellent. I'm really happy with that. The shaper likes stainless, that's for sure. 303 anyway, which is pretty easy to cut. As I did on the mill with the ends, I now cycle the other 7 pieces through, again taking a very light initial cleanup cut on each face so that I have one machined edge on all 8 parts. It's important to make sure the parallels are tapped down firmly on every one of these steps, by the way, since they are long, skinny parts. You're going to get taper in them if those parallels aren't well seated. I like the thin parallels for this because you can bend the parallel a little bit and you can see where it's bending. If it's bending under the part, then you know the part isn't firmly seated down on that parallel. That's a really common source of taper in parts, is the part not sitting perfectly on those parallels. After cleaning up one edge of all 8 parts, guess what happens? I'll give you a hint. Rhymes with refleuring. On long edges like this, I typically use a combination of the Noga blade tool, which works very well generally speaking, but sometimes leaves the occasional spot here and there and doesn't always get into the corners nicely. So I also run over it usually with a file if I still feel a little bit of something. When you're deburring, essentially what you're doing is either a tiny chamfer, or you can think of it as flexing the piece of metal that is the burr over so that it breaks off. Now I take that reference edge on that first piece and flip it around and tap it down on the parallel, and now we can do another light minimal removal cut on this face. Just like we did with the ends, we do one minimal material removal on each side before we measure anything, because you can't measure a machined surface against a factory or a rough cut edge. That isn't telling you anything. You have to have a machined face on each side, and you do a minimal cut so that you don't end up under dimension on those initial cuts. Then you can take your measurement, see where you are, and go from there. I'm also measuring both ends because it's a long part, checking for taper. If the machine isn't cutting well, now is the time to find out before we mass produce. Now I know where I am, so now I can start taking some heavy roughing cuts to get down close to my final dimension, again only on this initial setup part. In this case, I did a little experimenting and I found that 30 thou depth of cut on this 303 stainless was just fine. The shaper wasn't even flinching at that. Probably could have gone heavier, quite a bit heavier even, but I'm not in a hurry, and it's a 65-year-old machine. There's no need to abuse it. We're not in production here. Time is not money. Hobbyist time is cheap. Then I do a finishing cut and get myself on dimension for this initial setup piece. Then, once I'm happy with that dimension, I zero the hand wheel on the tool head on the shaper, or if this was on a mill, you would zero whichever axis you're advancing. At this point, zero the hand wheel if you don't have a DRO, and that's going to be your final dimension for all the other parts. Next, I'm going to bring in the rest of the parts, and I'm going to stack them in here all at once with the parallels set in a triangle, so they're all sitting on part of the parallels. And this is going to be an approximation cut, like this is not an accurate setup. I'm only using this to rough cut in all of these pieces all at once. And this is because this is a big time saver on the shaper. If you can do this kind of thing, you want the shaper cutting as much as possible and doing its mechanical overhead as little as possible. So a great way to do that is to stack multiple parts in the vise like this. But this is not accurate because you can't be ensured that each piece, especially the middle ones, is correctly tapped down on those parallels. I've tried using like small brass drifts and stuff to tap down each piece perfectly. Never works. So I only do this kind of part stacking for rough cuts, get me within finishing cut range of dimension, and then I finish cut each of the pieces individually. But again, we don't have to measure anything because we've zeroed the tool head at the final dimension based on the setup piece. So all I'm doing is doing a bunch of roughing cuts and double checking that I'm kind of in the ballpark of a finishing cut here. This measurement's technically unnecessary. And then I go through and I cycle the parts one by one, just setting my tool head to 0. Again, no measurements required because we did the measurements on the setup part. And again, if you're tricky and clever with this, you can get it to where every single part is within a single finishing cut range, and you just have to set the tool head to 0 and not even think about it. Just cycle the parts through the setup, which is very, very efficient. If you've got a little extra material left on there, more than you thought, then you might have to do multiple passes just so that you're not doing a single cut that's too heavy. Now I've got all 8 bars fully dimensioned all the way around. It's time to put some holes in them. So we'll do a slightly different mass production technique over here on the mill for hole making and other similar interior features. I'm going to start again with one canonical setup part, and I'm going to do all of my edge finding on this. I'm going to center up on X and Y because we have a 2-bolt pattern to put in the center of this part. And I'm only going to have to do this edge finding once. That's important because edge finding is super time consuming. So if we can do as little as possible of it, that's good. Now I'm going to center drill the 2 holes on each part and cycle them through with an end stop. And again, I don't have to edge find any subsequent parts. I don't have to measure anything. I'm just cycling the parts through with the end stop. There's also some trade-offs that you can make here with tool changing versus part changing versus traversals. Those are the 3 time-consuming things on the mill, is tool changing, part changing, and traversals. Especially head or knee movement, vertical movement of the spindle is the most expensive in terms of time. So in this case, I've opted to minimize tool changes, but I am doing a lot of X traversal and a lot of part changes. For me, I think this worked out well, but depending on the part and depending on the tooling and depending on how much you're traversing, it might be more efficient to, for example, do all of the operations on one end of each part and then do your tool change so that you're doing fewer traversals. Or if the tool change is cheap and part swapping is expensive, you can do all of your operations on one part and then change parts. So it depends on the setup and the tooling and so on. That completes the 8 grill bars though. I'm very happy with those. Those are very beautiful looking, all nice and identical. Now let's move on to the tie bars that go through those holes, tie everything together. I'll just zip through these because they're trivial parts. Very simple stainless steel round bar. I rough cut these to length. Deburr, you got to do it on the lathe too because the burrs are going to interfere with the collet gripping properly on the end of the part. So those hacksaw cuts get deburred, and then these just get cleaned up and face down to length. One slightly unusual part is they get a very tiny blind hole drilled in the end of each one. More on that later. It's pretty interesting. Then I'll test fit those. That looks good. fact, I bet if I space the bars out right now, it's going to start to look pretty fire gratey. Yeah, look at that. It's starting to look like a fire grate. And I'm happy to say the ends are all flush, so that seems to have gone well. Now I need all the little spacers that go between the bars. Those are going to be made from this other piece of stainless round bar, and it's a chance to show some other mass production techniques on the lathe. The lathe is actually very good at mass producing parts. There's lots of different ways you can do different things, but here's one way. So I'm going to face off the end, as is tradition. Now the amount of stick out there is calculated for how many parts I can get out of one setup, and I'm going to drill through that number of parts all at once. In this case, I'm only going to fit 2 parts. You got to calculate the width of each part plus the width of the parting blade between each one, and the rigidity of your material is going to limit the amount based on how much stick out you can have. So 2 seems to be about all I can get away with. I don't want to go any further out than this, but I make sure to deburr as I go along. That's very important when mass producing on the lathe, because especially with this corner knocking off, you're only going to get to do that once. That's a lot easier to do on the lathe than before you Yahtzee the part off. After Yahtzeeing off the first one, I again deburr everything. Then I move in by the width of the part plus the thickness of my parting blade, and then I just Yahtzee off another one, making sure to pause partway through the Yahtzee to deburr the back edge. The only thing you can't deburr in situ is the back side of the hole, but that's easily done on the bench. Then after that first batch of parts, in this case only 2 in a batch, I face off that face again, and this is important because on my DRO, I have the 0 set to the start of a batch of parts, and I can move my parting blade over to that 0, and you can activate the human bar feeder and pull the bar out until it just touches the edge of that tool. This is in fact how CNC lathes mass produce parts. If you're using a regular chuck, at this point you don't even have to measure anything or touch off any tools, because you know the end of that part is at 0, same as it was before, and you can just start parting off more of them. However, because this is a collet chuck, I do have to touch off the tools again, because a collet chuck pulls the work back a little bit as it tightens. So just a little gotcha, but that touching off with the parting blade is a good approximation. It still lets you know that you're going to have enough material sticking out to get another batch. After 14 of those, I then make 4 of the little end caps. And these are the same as the spacers, but they have a really deep center drill in them. You'll see why in a second. Yahtzee off 4 of those. And now we have a whole bunch of pieces that, yeah, you guessed it, need deburring. This is all the detritus from the backside of each of the parting cuts, which we weren't able to reach. So now we can go through, clip off any burrs, and deburr the backs of those holes. In principle, now I have all the parts needed to assemble the fire grate, so let's do that and see what happens. This is all very satisfying, I have to say, to slide all these little bits together. It's like Lego. One important dimension on this whole assembly is the overall width of it, because it has to fit between a couple of rails that we're going to make. There's a track that this thing slides in, and mine is a bit oversized. So I took it all apart and measured all of my little spacers. I had a few of them that were oversized, so I filed those down a little bit. And once the spacers were all dead nuts on dimension, then the overall assembly was also dead nuts. There's a lot of places for accumulated error there, so any small amount of error in all those parts is going to add up. Now it's time to stake this whole thing together. And we're going to stake it together using this hole in the middle and that taper that's created by the center drills. We're going to hammer a punch into that hole in the end, and it's going to spread the end out and lock those tie bars in place. The reason we're doing this is, well, because the drawings say to do it, but also I think the reason it's done this way is because it's a lot easier than, say, welding the pieces together. Stainless welding is out of the reach of your average hobbyist, but also something like bolts could be used, but fasteners aren't going to stand up very well to the extreme changes in temperature. They're going to work themselves loose over time, so physically, mechanically staking the parts together or peening them, or however you want to phrase that, is I think a really good way to go. I did reach a point where it just wasn't getting any tighter though. The whole assembly should get tight from this, and it wasn't, and it's because I was bottoming out on the end buttons. I need to be hammering just on the ends of the inner tie bars. So I put a ball bearing in my bench block, and I'll rest one end of the inner tie bar on that, and that will allow me to do my punching force straight through the bar and not on the end buttons itself. That worked really well. Everything got tight, although it did slip a few times, and I smushed my end buttons on the ball bearing, Oops, but that's harmless. I filed the burrs off created by that, and the whole assembly did get nice and tight, so pretty happy with that. Now let's do a quick mock-up in the locomotive, see how it looks. Oh yeah, look at that. That is a fire grate. Well, I was very pleased with myself at this point. I even took the final thumbnail photo. Figured I was done. I was cleaning up the shop, ready to pack it in, and I realized I forgot to chamfer the corners. Yeah, as you can see on the drawing in the corner, the corners of all these bars are supposed to be chamfered. And I almost didn't do it. It's not mechanically necessary as far as I can tell, but I mean, chamfers are what separate us from the animals. We gotta do it, right? This may be a little bit of a challenge, however, because I can't take the assembly apart. It's all staked together. I don't want to start remaking all these parts. And I don't want to do it on the milling machine because the milling cutter spins, which creates forces in all different directions. And this assembly is weak in one axis, but strong in the other. So these bars are very stiff this way, but if I'm putting forces on them this way, they're going to want to vibrate. So if I try to mill these chamfers, they're going to vibrate because the milling cutter is putting forces in all directions. However, the little shaper cutter here is only putting forces in this direction if I mount it this way in the vise. So the bars are strong in that direction, and so the shaper should do a much better job in this particular case. I am going to put some little spacer blocks in there because I'm a little bit concerned that the vise could squish the bars. I put 2 in there, which is all I have on hand that will fit, but that way the force of the vise is being taken by 4 bars instead of 2, and I'm clamping right under the spacer buttons, so the inner bars should all be well supported anyway. I think it'll be okay. Then I'll set this up with a 45-degree angle, and I can cut these chamfers all the way across. I wasn't certain how this was going to go, if the setup was rigid enough for this, so I took a light cut across initially, just to get the feel for it. And Swarfy came and had a look. He hasn't really inspected the shaper much yet. I had a word with him about safety, but he assured me he was fine, and the man doesn't tell him what to do. I mean, he's got a green mohawk. And you know what? I respect his life choices, but he doesn't have any fingers, and there might be a reason. Just saying. That initial test cut went great, though, so I took some heavier cuts. I ended up doing 20 thou passes on this, and it was handling that no problem. Again, the limitation here would be the setup, the strength of the setup, and this seemed to work just fine. So I took a couple of passes over there to final depth of cut, and this went really, really nicely. The shaper is doing a beautiful job. Now this was not fast because this is kind of the worst case efficiency-wise for the shaper. The way you get efficiency out of a shaper is by minimizing step overs and maximizing stroke length. And here we're doing the opposite. We're taking short strokes and stepping over a lot, and even worse, I'm stepping over between the bars, so there's long periods where nothing is happening, it's all just wasted motion. The shaper also has wasted motion at the beginning and end of each stroke because it has to accelerate and decelerate. So, not an efficient setup, but the shaper did a nice job, and the forces were good for the assembly. A person could also file these chamfers. I considered that, but filing stainless is really miserable. I also considered just using the belt sander. I'm sure that would have also worked, but the shaper did a much nicer job than either of those methods. So there's the final fire grate, this time for realsies. And it looks very nice. I'm happy with it. But at the ends of these videos, I always like to show the part functioning and how it's supposed to function. But how do you demonstrate the functionality of a fire grate? Easy. Easy. Perfect. It successfully supported a fire and was no worse for the experience, so I think it's a fire grate. Success! I realized this was not the most exciting component or assembly to build, and hopefully I found some ways to make it at least a little interesting to watch. I actually enjoyed making it. Sometimes these simple parts are fun to make because you can kind of shut your brain off and just run the machines. Thank you so much for watching. Thanks to my patrons for making all this happen, and I'll see you next time. The trick was, it's glued together.